Homework 3.1, Quadratic Functions, video number 4. Homework due at 11:59 p.m. on Wednesday, May 27th. The next two videos will correlate to questions 5, 6, 7, and 8 in your homework. Actually, a disclaimer. I'm about to show you more than what is in any one individual question. For example, number 5 asks you to do some but not all of these things, but throughout the homework, all of these things will be asked. So I'm just trying to get the biggest bang for my buck, if you will. So we're going to graph a quadratic function, and I'd like to do two examples, one in this video, one in the next. And if you notice, I got a laundry list of 8 things we're going to do, all of which we've already done in some capacity, either in this video series, or previous video series. For a given quadratic function, does the parabola open up or down? What is its y-intercept? What are its x-intercepts? Where's the vertex? Where's the axis of symmetry? What is the symmetric image of the y-intercept? Graph the thing, and find the domain and range, which will be easy once we have the graph. In fact, the moment we can find the vertex, we can find the domain and range. I'll hopefully remember to verbally tell you why, but at the end we'll pull it off the picture. Okay, so our function is f of x equals parentheses x minus 1 squared plus 2. Let's start with whether it opens up or down. Remember, the whole does it open up or down question revolves around the leading coefficient being positive or negative. And when you're in standard form, the leading coefficient is the number in front of the parentheses. In this case, because the number in front of the parentheses is an implied 1, and more specifically implied positive 1, this parabola will open up. To find the y-intercept, we simply have to plug in 0. Now be careful. When you're in standard form, plugging in 0 doesn't kill everything it touches. 0 kills things it touches in terms of multiplication, but this 0 isn't being multiplied by anything, so we actually have to work it out. It's not too hard. 0 minus 1 is negative 1, and so negative 1 squared is 1, and then 1 plus 2 is 3. So we know that this graph will cross the y-axis at 3. Now the x-intercepts are always going to take some work, because you have to solve an equation. You have to, in this case, or in any case, you solve the function equal to 0. So let's take this out to the side and see if we can solve this. Solve parentheses x minus 1 squared plus 2 is equal to 0. We've been down this path before. Go back to homework 1.5 about quadratic equations. One way is to write the parentheses twice, foil it open, gather like terms, and then either factor or use the quadratic formula. But I wouldn't do any of that on this one. You know why? You remember why? When you're solving a quadratic equation, and there's only one x term, you can, and frankly should, solve it by using square roots. In other words, just start getting this x by itself. So we're going to have to start getting it by itself by subtracting 2 from both sides. That cancels the 2's on the left. It leaves x minus 1 squared on the left. And on the right, 0 minus 2 is negative 2. And then we break out the square roots. So square root the left side and square root the right. We have a problem. Note on the left, the square and the square root cancel. And on the right, we're supposed to use plus minus because that's one of the steps in solving an equation using square roots. Go back and watch the corresponding video for homework 1.5. The problem is with the negative under the square root. The 2 we really can't do anything with, but if you force me to, I'll split off the negative 1 under its own square root. Hey, I see a square root of negative 1. Remember what that becomes? I. So we get x minus 1 equals plus or minus I times the square root of 2. And I can still solve it. I can add 1 to both sides and get 1 plus or minus I square root of 2, which is what you should get if you chose to bust open the parentheses and use the quadratic formula. But what does this mean? Well, these are supposed to represent where the graph crosses the x-axis, but the x-axis has only real numbers and these aren't real. So what does it mean when you're looking for x-intercepts and they're not real? That means that the graph has no x-intercepts. There are no x-intercepts. Again, let me say that again. If you're trying to solve the function equal to 0 to find the x-intercepts, and they come out to not be real, I want to say complex, but real numbers are technically complex. If they come out not real because there's an I, that means no x-intercepts, or at least these aren't x-intercepts. If we had more solutions that were real, they would be x-intercepts. Wait, a parabola can have no x-intercepts? Sure, if it opens up and you raise it high enough, then the vertex doesn't reach all the way down to the x-axis. Or vice versa, if it opens down and it's low enough. So that's going to happen sometimes. And that's going to make this a little tricky to graph because we have no x-intercepts. But let's just keep going. The vertex. All right, we got a formula for that, or an approach, I should say. If your function looks like this, and ours does, you can pull the vertex out by changing the first sign but keeping the second. So no work is required here. We just have to pull the two numbers out, but change the first number's sign. So what's the vertex going to be? 1, 2, and now it makes sense that there's no x-intercepts. No x-intercepts. There is a y-intercept. Parabola will always have a y-intercept. But it makes sense that there's no x-intercepts because the vertex is over 1, up 2, and the parabola opens up. So it already starts out above the x-axis and just keeps going up from there. Axis of symmetry, that's pretty easy. It's always x equals the x-coordinate of the vertex. Now, as far as the symmetric image of the y-intercept, it's probably easier if we start graphing this. I know that's the next part, but we know it's coming up. So let's graph what we have. So what do we know? We know that the graph opens up, so I'll just draw that as a reminder. We know the y-intercept is at 3, 2, 3, so we'll put it out there. Go ahead and label it 0, 3, because that's its coordinates. We know there are no x-intercepts, and we know the vertex is at 1, 2, which is right here. And we know the axis of symmetry is x equals 1, so it drops straight down through the vertex. So what is the symmetric image of the y-intercept? I'm going to draw this a little bit more spaced out. I should have thought about it and spaced out my numbers on my x and y axis a little bit more. So let's do it this way. 1, 2, 3, 1. All right, so our y-intercept was there at 0, 3, and our vertex was at 1, 2, and our axis of symmetry comes dropping in from the sky right through the vertex, and that's x equals 1. So where is the symmetric image of the y-intercept? In other words, if we take the point 0, 3, where is its mirror image across the red dotted line? Well, first measure how far off the axis it is. That's not too hard. This axis is at x equals 1. This is at x equals 0. That's 1 apart. This number will always match that one, by the way. Think about it. So its mirror image should be the same distance, but in the opposite direction, so one space to the right. So what would the coordinates of the symmetric image be? Well, both of these points are up 3, but if I'm at 0, go 1 to the right to get to the axis, and then 1 more to get to the symmetric image. I just went over 2. One thing you'll always notice about this point, its x is just double this number. Not so subtle hint for the bonus question. All right, so we got the symmetric image. Really, all you have to do is double the axis of symmetry number. That's all. All right, so our symmetric image is at 2, 3, And there's, well, we don't have the graph yet, but we got 3 points, and we know it's a parabola, and we know it's opening upwards. If you really wanted more dots, go stick in some more numbers, like 1, 2, let's stick in 3, and maybe take its mirror image. But I think we have enough information here. In the homework, sometimes when you graph a parabola and you click on the parabola tool, it will ask you to click the vertex and then click an intercept, or actually any point, and it automatically knows where its symmetric image is. Oh, what about the domain and range? Well, this is easy. This is a polynomial function. Its domain was going to be all real numbers from the get-go. But the graph confirms that because the parabola goes forever left and right. So our domain is an interval is negative infinity, comma infinity. But what about the range? Range spot at the top. What's the lowest y value? The lowest y value is 2, and it's included. It goes up forever, so it goes up to infinity. And honestly, we could have written this the minute we knew the vertex, because we knew 2 things at that point. It opens up, and this is its lowest y value. Lowest y value upward. Domain is always everything for quadratic functions. All right, so as you can tell, we did a lot there. The X Intercept slowed us down a little bit, but this was never destined to have any. And if you think in advance, well, you would have to know the vertex first, but if you had the vertex first and you know which direction the parabola opens, you may be able to anticipate that there are no X Intercepts.